Our first example of instruction format is this instruction add CL, which we already tried to assemble in our little simple program right here. So what we ended up with as a result of assembling this program, that the encoding of this instruction looks like 02C8, and we already tried to interpret certain bits from mode RM byte and from 02, and we found out that it agrees with an idea of adding them together by this instruction and storing the result in register CL. Now, because the source and destination can be swapped between mode RM and reg field, and because the D can also be swapped, this same instruction can be encoded this way, 00C1. It is just that our assembler chose to encode it as 02C8. But let's stop our debugging session, and instead of writing instruction mnemonic and using the actual operands in our register and registers, we can simply say that we want to write a binary code for the next instruction. And we can say even in the code segment, we don't have to use these mnemonics. We can just specify what bytes we like. So how about 00C1? Okay, so on the next line, I'm going to write 00H, okay, and followed by 0C1. If you write hexadecimal values, they must start with digits 0 through 9. So it's very common to do it like this, 0C1. And of course the prefix again is H. So now, directly in our code segment, directly in our procedure, right here I'm just using binary encoding of something that should look like this when we disassemble this code. So let's build this. And assembler really doesn't care how you specify your instructions. You can just hard code them in binary values if you'd like. So I picked this binary value right here from this handout. Let's again start in debug mode and switch to disassembly. And you can see that both of these instructions, add CL, which are basically the same instruction, can be encoded in two different ways. So the second instruction is the same instruction, and it's up to the assembler to decide which one to generate, but you see that there are some duplications because of the flexibility in the direction and the values stored in mode reg RM. So anyways, so with respect to this new encoding of the same instruction, this little diagram explains to us that basically starting from the left hand side, these bits right here, these 6 bits set to 0, indicate that this is add instruction. Then the next bit right here indicates the direction, and this direction is indicating that we're adding the reg field to the RM field. Basically, reg field is the source of the data, and the result will be stored in the operand indicated by RM. In other words, RM should be pointing to CL, right, the destination, and the reg field should be extracting value from AL, right? So from AL we do addition of both of them, and then we store the result in register CL right here. Okay, so and here this field set to all zeros indicates that the register is AL, and the combination of 1 1, which indicates that RM field is a register. We take this encoding as an encoding of a register, and if we look it up in the table, it'll indicate that this is encoding of register CL. So this is encoding of register AL, this is encoding of register CL, and this specifies that both of these things are registers. And so also 1 indicates that these registers are 8-bit size, basically 1 byte in size. But quite interesting situation is that if this bit would change to 1, then here we could use this encoding with 1 here and 0 here, and then this will become our source, and this will become I'm sorry, it's actually the opposite way. This will become the destination, this will be register CL, and this will become the source, which is register AL. So this bit in combination with mode reg RM byte will yield 2 possible encodings of the same instruction. So but it's pretty routine type of approach, because there's always instruction manual, instruction reference manual officially. There's this documentation that we will use in our laboratory to basically look at the byte codes and be able to explain every part of what they represent and what they tell us.